Most people look into data and see numbers. Data analysts look into the same data and see the answers. That difference isn't talent, it's skills. And that skills can be learned. Welcome to this course on Python for data analysts. Now we know that every organization today is surrounded by data. Let it be sales figures, customer behavior, performance metrics, and even reports. But raw data on its own doesn't drive decisions. What creates impact is its ability to collect the right data, clean it, analyze it, and clearly explain what it means. And that's what exactly a data analyst does. In this course, we'll learn Python for data analytics, the most widely used tools for modern data analysis. More importantly, you will learn how Python fits into the complete analytical workflow exactly the way it used to in real-world projects. We move step by step from Python fundamentals to data cleaning, analysis, visualization, automation, helping you think and work like a professional data analyst. In this course, you'll learn how to set up a Python analytics environment, use Python fundamentals for data analysis, clean and prepare real-world datasets, analyze data using NumPy and Pandas, perform exploratory data analysis, which is a process of EDA, create clean, business-ready visualizations, work on real-world analytical projects, and finally, we automate reports and workflow using Python. Before we dive in, here's a quick question for you to answer. Which Python library is mainly used for data cleaning and analysis? Is it NumPy, Pandas, Matplotlib, or is it Seaborn? Do let me know your answers in the comment section below. Also, if these are the type of videos you're interested in, do like, share, and subscribe to Simplilearn. Now, let's get into the part of what a data analyst actually does. Many people hear the term data analyst, but the real work happens in a few clear steps, and this slide captures them perfectly. The first step is collecting data. In real projects, data does not come from just one place. A data analyst works with CSV files, Excel sheets, company datasets, or sometimes data coming from websites and applications. Using Python, we bring all this data together into one place so we can start working with it. Once the data is collected, you'll notice something very important. Raw data is never clean or even inconsistent entries. So the next step is cleaning and preparing the data. This is where the data analyst spends a lot of time making sure the data is accurate and usable. After the data is cleaned, we move on to analysis and visualization. Here, the goal is to understand what data is trying to tell us. We look for patterns, trends, and relationships. Using Python, we create simple and graph that makes the data easier to understand, even for non-technical people. Finally comes the most important part, which is presenting insights and automating reports. A data analyst's job is not just to analyze data, but to explain it in a way that helps business make decisions. Instead of repeating the same work every time, Python is also used to automate reports so insights can be generated quickly and consistently. So overall, a data analyst collects the data, cleans it, analyzes it, and then turns it into meaningful insights that drives better decision. Python plays a key role in every step of this process. Now that we have understood what a data analyst does, the next obvious question is why Python? The first reason is ease of learning and readability. Python looks very close to normal English, which makes it easy to read and also write, even for beginners. Compared to older programming languages, Python requires much less code to perform the same task, which saves time and reduces errors. The second big reason is Python's rich analytics ecosystem. Python has powerful libraries like NumPy for fast mathematical operation, Pandas for working with tables and datasets, and also Matplotlib or even Seaborn for creating visualization. With these libraries, complex data tasks become simple and efficient. Another important reason is flexibility and scalability. Python works well whether you are analyzing a small Excel file or handling a larger dataset. It also helps automate repetitive tasks like daily data processing or weekly reports, which is extremely useful in real-world projects. And finally, Python has a strong industry adoption and career value. It is widely used across finance, e-commerce, healthcare, technology, and also many other industries. Knowing Python opens doors to roles like data analyst, data and business analysts. So overall, Python is easy to learn, powerful, flexible, and widely accepted in industries, which makes it perfect choice for for data analytics. Now let's compare Python with, because many people ask, do we really need Python when these tools already exist? Let's start with Python. Python is powerful because it supports automation and scripting. It can handle complex logic and work with large scale data. With Python, we can clean data, analyze it, visualize it, and even automate the entire workflow in one place. Next is Excel. Excel is great for quick analysis and simple visualization. It's very user friendly and works well for small data sets. However, when the data becomes very large or logic becomes complex, Excel starts to struggle. Now let's talk about SQL. SQL is mainly used for data extraction. It is excellent for querying data sets, filtering the data, and joining the tables. But SQL alone cannot handle machine learning, advanced analytics, or even automation. Finally, is very common in statistics and data visualization, especially in research and academic work. But when it comes to building production ready applications or automating end to end workflows, R is less commonly used compared to Python. So, in real world projects, Python often works along with Excel, SQL, and sometimes Python acts like a central tool that connects everything, making it the most versatile option for data analysts. Now, let's take a look at where Python analytics is actually used in real world. Python is not limited to one industry. It is used across many domains wherever data is involved. First is business and marketing. Companies use Python to analyze customer behavior, track campaign performance, understand sales trends, and even predict future growth. Python helps businesses make smarter decisions based on data instead of guesses. Next is e-commerce and product-based companies. Here, Python is used to analyze user activity, recommended products, optimize pricing, and improve customer experience. Almost every online platform relies on Python analytics to understand how users interact with their products. The third area is finance. Python is widely used for financial analysis, risk assessment, fraud detection, and forecasting. Banks and financial industries rely on Python to process large volumes of data quickly and accurately. And finally, Python analytics plays a major role in healthcare, sports, and education. In healthcare, it helps analyze patient data and improve treatment outcomes. In sports, it's used for performance analysis. In education, Python helps track student performance and learning trends. So, no matter what the industry, business, finance, healthcare, or education, Python analytics help turn data into insights that drive better decisions. Now let's talk about Python ecosystem for data analytics. One of the biggest reasons Python is so popular is not just the language itself, but the powerful libraries which come with it. We'll start with is mainly used for numerical computation. It helps Python handle large amounts of numerical data efficiently and forms the foundation for many other data analytics libraries. Next is Pandas, which is one of the most important libraries for data analytics. It helps us work with data in the form of tables similar to Excel but more powerful. It is used for data cleaning, filtering, grouping, and transforming of data. Once the data is ready, we need to visualize it, and that's where Matplotlib comes in. Matplotlib is used to create basic charts like line graph, bar charts, and pie charts, helping us understand data visually. On the top of Matplotlib, we have which is used for advanced and statistical visualizations. Makes charts more attractive and easier to interpret, especially when working with patterns and comparisons. For machine learning analytics, Python provides Learn. The library is used for tasks like prediction, classification, and clustering, and it integrates smoothly with Pandas and NumPy. And finally, we have Jupyter Notebook or even Google Colab. These tools are used to write code, run experiments, and also visualize results step by step. These are very popular for learning, analysis, and sharing results with others. So overall, Python ecosystem provides everything a data analyst needs, from the data processing and visualization to machine learning and experimentation, all in one place. So for this setup, I have 3 free setups that you can create in your laptop and when to start execution of Python for analytical part. The first one is absolutely free for you. So you just need a Google account and then just click on Google Colab. and just open the first link. Now here you can see all my other files are there. You can just click on create new notebook and you'll have a sheet to work on. Now here all the tools that I'm using is having line by line execution, which is every line can be executed only by clicking on them. Now for Google Colab, the first thing you have to change is the name. So give it any kind of name. And as you can see, we have other options of rename, moving, move to trash, save a copy in drive, open notebook, open new notebook. You can integrate Git also here and also download and print. We have edit tools also. So you can select the cells, copy and paste, and you can delete the execution already executed cells, which will have the output in it. Now here there is a plus code option, which basically enters a coding line. But if you want a clear text to be there, so you can just click on text and you can enter the heading. And also here you can see you can either edit the cell or delete it, and you have other options of the each cell over here. The Colab runs in a browser, gives you a free Jupyter-like notebook and needs only a Google account. It is great for beginners because there is no installation and everything runs on Google servers. So let's just try an example. Let me just import a library, import Pandas, and just run it. So as you can see, it will show the amount of seconds that if there is any output, output also will be displayed. If you look at, you will have RAM and disk. So this is for if you want to perform high-end operational ones, you can change this runtime type, change the runtime type, the T4 GPU. This gives a more wider range of execution without any limitations. Now here are some disadvantages of using Colab. We know that the execution process it's a little bit less compared to the Jupyter Notebook or VS Code. Second one is every time you open the notebook, you need to upload the documents which was already there, which you have worked on, etc. Next, the second way is VS Code plus Jupyter. So for that, you need to install VS Code first. So just type in VS Code and the first link, you can just open it. And here you will see an option of download it for Windows. You can click on that, install the process, just click on next, 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 and you will be able to see VS Code here. So let me just open VS Code. So as you can see, these are my few previous projects. So you can just cancel it out. And this is the execution. After installing VS Code, you'll get like this. Now, how do you execute this via Python Jupyter Notebook? So as you can see, there is extensions here. So just click on that, type in Jupyter by Microsoft, and there will be an option for you to install. So if you install it, you can have a Jupyter-like notebook. Now, before this, you have to make sure the Python is present in your system. So for that, you can just type in Python and the latest version, whichever is it, you can just download it. So go on to python.org and downloads. You can see or get standalone installer for Python. You can just click on this. The download will start and you can again install it similar to Visual Code. Now here you will find an option of Python 3.14. So if you just click on that, the installation process will start. But here is a major thing that people miss is to use admin privileges while installing py.exe. And also there's the most important one, which is add python.exe to path. Now this initiates Python all across your system so that you don't need to run in a particular folder to run the Python code. So if you just click on install now, the installation will start. Since I already have Python, I don't really need to do that. Now, how do you confirm that Python is already installed? Just open Windows R and command prompt, CMD, and command prompt will be there. And also just click on Python and version. It should display the version that you have downloaded. So here I have 3.13.7. So this is for your system, and you can open Jupyter here also. So if you just type in Jupyter Notebook, it will run an online server and start a Jupyter Notebook. So as you can see, every little small thing will be there in the command prompt. And also if you're running through this, any Jupyter Notebook, that any changes that you do, it will be reflected in the command prompt. So let me just show you. This is the Jupyter notebook you will be getting. If you create a new folder, you can just create a Python notebook. And as you can see, it got updated. And again, it's a box platform. And you can just code, import pandas, and run it. So before running, it is star, and after running, it is 1, showing that the run is successful. Now here you can see every time I run a code or do some changes in this file, the command prompt will be updating. Now to make sure, if you don't want to install the Python in the command prompt, again go to extension, type Python, and just click on Python from Microsoft, and you can just install this also, where you will be able to start a Jupyter notebook. Now how you will be able to start a Jupyter notebook after installation is click on Control Shift and P, and here you will see the different extensions that you want to start. And if I say create new Jupyter notebook, it has created one. And again, you can see a box pattern here. Same like Jupyter notebook and Colab, one is code, markdown is basically the text, run all, and outline. So here you can just change the name, rename it, and you can just say import. And how do you run this? Just click on run. So if you just click on run, the kernel should start up. So it is taking some time to connect to the kernel, but it will run, and you can start coding multiple things at a time here and use the text box to identify the heading. Now here you can see import that has run. Now the third way of executing this Python is to use a Anaconda navigator. Now how do you install that? Just Anaconda navigator, open that up, the first link, and you can just download. If you just click on this, it will start downloading, and then you can just click on the folder that was downloaded and start installing. Mind it will take many minutes to install the Anaconda, but after installation you will get Anaconda in your system. So when you open that, it will take some time to open. So as you can see, it is initializing. So we'll just give it time to start loading. Now why I'll be using Anaconda Navigator is it has Python, Jupyter, and many data packages in one go. Anaconda is a distribution that installs Python, pulls data libraries such as NumPy, Pandas, etc. And Anaconda Navigator, a GUI launcher. From Navigator, you can open Jupyter Notebook within a few clicks. Now, if the Anaconda Navigator starts, it'll look like this. So you can just install PyCharm and install Toolbox, etc. So you can just click on connect and you can sign in. So all your information will be there. And let me just check because I had downloaded. Yeah, here you can launch the Jupyter Notebook directly from here. You also have Jupyter Lab. So if you just click on launch, it will start with a Jupyter Notebook. Now, as you can see, a Jupyter Notebook has opened. Again, it's the same thing that we had opened via the command prompt and also the VS Code. So again, you can just create a Python and just run. It's the same interface. Let's just execute the same thing and it should run, and there are no errors. So out of these three, whichever is convenient to you, you can start using them for data analytics. Here in this entire course, I'll be using Colab, Google Colab, because you guys will already have it online, so you can just open it instead of waiting for the whole download process. Obviously, you can download it and use other types of execution codes. The same code will be working in all the platforms. Now, let's just run a small program in the notebook so we can cross-check it. First, let's say a simple number and a string. Let's say age is equal to 25. And let's say course name is equal to Python. Now, since this is a string value, it should be Python for data analytics and course name. So here you can see age is 25, course name is Python for data analytics. It has printed. These are the names that stores values. You can reuse these things, etc. Course name they denote that they are variables which carry a certain amount of value inside them and can be reused throughout the entire program. So let's just name them as variable, and I don't want any code. Now the next type of initialization that we are going to do is list. So let's just see what lists are. So we can just name it lists. And for the coding part, let's say monthly sales is equal to 120, 135, 150 and 160. So these are collection of data in one, which is list. There are two types where you can collect data, which is list, and one is mutable and one is unmutable. And then let's just print this. So let it be monthly sales and just run it. So you can see it is 120, 135, 150, 160. Also, if you observe, a list is an ordered collection. We'll later convert these into pandas, series, or even data frames. So make sure it is in order. Next, let's take a look into a simple looping function, which is useful for data analytics. Basically, loop is a iterating factor. So first, I'm using a for loop for looping. So we have for sale in monthly sale. That means any value from the set of monthly sales. Now here I have a loop which says for sale in monthly sales, print monthly sales, comma sales. That means for every month, what is the sales value it should be printing. In a loop, it should print. So every value, say, it should give me monthly sale is equal to 120, next monthly sale is equal to 135, etc. So let's just run this loop and see the output. So as you can see, the first monthly sale is 20, the second monthly sale is 135, etc. Now let's just start with a quick analytical function, very small one. So the first one is, let's say total is equal to sum of monthly sales. Now here we are calculating the total amount of sale value, which should be 20 plus 50 plus 60 all in together with one function, which is sum. Let's also get the average. So let's say average sale is equal to total sale divided by length of it. So let's just say divided by len, which calculates the length of the array of monthly sale. Now this gives the average for us. Let's print the total sales and also let's print the average. So let's just run this code. Let's see what the error is. So there's a spelling mistake. Total. Again, there's spelling error. Let's just rectify that. And here you can see the total monthly sales is 565, which is addition of the array that we have given, which is 120, 35, 150 and 60. And coming on to the average value will be 565 divided by 1, 2, 3, 4, which will roughly give us 141.25. Now this is very small analytical part that is average and sum that we are using. Now before we get started, let's just refresh our Python knowledge. So as we all know, the first one is variables. And what are the different kind of variables? It is int, float, string, list, and dictionary. So these are the different kinds of variables. The second thing that you have to concentrate will be conditional, looping. And the third thing will be functions. Now these are the three things that we'll be concentrating on first. The first thing is variables. Now we know that we are having int, float, string, list and int. So firstly we'll start with int. Now if I give month is equal to 1, this is an integer which is a whole number. Now if I want a point-wise number, we need a float. Now if you don't give, suppose month is equal to 1, this is also the same thing, but Python is so intelligent that it understands even without initiating this part. So even if I don't use int, this will be initiated as int itself. Now similarly for float, if I want to give some float value, which is revenue is equal to say 123.5. Now revenue will be considered as a float. You can also give float revenue is equal to 123.5. This is also good enough, but Again, you don't need to initialize it until it is necessary, since Python is intelligent to figure it out itself. So after the float, we have string. Now, how do you initiate string? So let's say product name is equal to, say my product is a pen and the pen is, say, gel. So you can just initialize the product name with double columns. Now, keep in mind any character or any kind of string that you're initiating, it should be, this will be a string. Next, we have list and dictionary, which will come to it later. Now let's print all the things, revenue, and let's say I want product name also. And let's just print it in an array format. So here you can see 1, 12.35 and gel as a return product. Now what about list and also dictionaries? Now how do you initiate list? We have already done that, which is monthly sales. Let's keep it small, is equal to, just have a box and give the number, whatever number you want, 20 or even 135 or even 150 and 90. Now this is your list. Now it's a little bit different for dictionary. So for that, we'll say monthly, let's say I'm taking summary, is equal to curly braces. So since this is 2D array, basically is a dictionary, so the first one will be month and followed by, which month is the first month? It's January. And let's just, after that, the first initialization, just give comma, space, and enter the second attribute, which is sales. And what is the amount of sales that done in January, which is 120. And next attribute I'll be using is target, and then 100. Now, if you run this and print monthly summary, it should be a array. As you can see, first month, January, then we have sales 20, then we have target as 100, which is initialized. So for every month, you can do the same thing. Now to summarize all the necessary things in Python that you should be knowing, int is a whole number, float is a decimal number, str, which is for string, is for text, list for ordered collection, and dictionary, which is dict, for key value data. Now moving on to the next, which is the second part, which is conditional loops. Now how do you execute conditional loops? Now we'll see a tiny list of monthly sales and print only the month that beats the target. Now here, out of the entire set of monthly sales, we need only few of the things that are crossing the target. Now how do you do that? If the condition performs, then get inside the loop. That's how conditional looping or conditional loops work. So as usual, we have monthly sales is equal to 120, 135, 150, 90. We are going to reuse that itself. Let's set the target. I need only sales which are 100 and above. So for that, the code should be for sale in monthly sales. This is the condition. And next we have if condition. So if sale is greater than 100, or target if you can set it. Let's set target and loop it. Then we have to print above target sale. And let's print the sale amount. Now we have to initialize target here. So just click on enter and let's set the target, which is target is equal to 100, and run the code. So as you can see here, we have above target of sale is 120. So let's cross check with it. The first one is above 100. So 120 is above the sales target, which is 120. 135 is above, 150 is above, and also 160 is also above. Now here you can see 150 and 90 is not printed because it is not above the target limit. Now if I changed my target to 150, there should be no values actually. So let's just run it, and there are no values which are above the target. So this is all about conditional looping. So for your simple understanding, if checks a condition, for goes through each sale in the list and we only print when the condition is true. Now this is a simple single line looping, single conditional looping. Now we can move up to multiple amount of conditions and then loop it for our execution purposes. Next, we'll discuss something called as enumerate. Now, what is enumerate? First, let's start coding and I'll explain you. So, with the monthly sales, let's just add the month names, which is month names is equal to, let's say, since it is a string, Jan, Feb, March, April, and let's end it up with May. These are the month names that I've initiated. Now, let me finish this with for condition for I, sale, in, enumerate monthly sales. And I have a if condition, which is if the sale is greater than the target, which I'll be changing it back to 100. And then we have print month names with I in it, and then comma, hit the target in the box with the value. What is the difference between the previous one and here one? I have added enumerate. This basically prints the index. It tracks index as well as the month names together. So for that condition, we use enumerate. So let's change the target to 100 and let's run this and compare the result with using enumerate. Each month is been printed. So this section I've already given, hit is also given, and also with the value. Now enumerate prints month name of I. So it will start with 0, which is Jan. It checks with Jan's value. Jan's first value is 120, which hits the target. So we have 120. Then Feb, it goes with the second one, which is I value will turn into 1, and then 2, and then 3, and then 4, and this gives the values. So basically, enumerate is index plus the value. This is pretty important because when you're doing data analytics, you will want the position which is the index to be captured, so you can compare multiple arrays or multiple columns, etc. Now, where you will use this enumerate? Instead of manually managing an index counter, enumerate gives you both index and value in a clean way. The third thing that I talked about is functions for analytics. Now let's create a simple function to know how functions work. So let's start with initializing a simple function. So for function, we have def space and the function name. So here I'll be calculating the discount and I'll pass a attribute which is revenue. So for any function, it's like def, the name, and the functions or the values that we have to put inside for that particular block to execute. So after this, what should the calculate discount functions do when it is called? Now here are the things that I will prefix so that we can accordingly code. First of all, the function should have the following feature. So what are the things this function should have? Returns the discounted amount based on the revenue. This is the revenue. So this we can use using a conditional format, which you already would have got the idea. Now coming to the second part. What are the discounts? For 10%, if revenue is greater than or equal to 10,000. So the first discount is going to be 10% if the revenue is crossing 10,000. And similarly, I will be providing a 5% discount on 5,000 and up. And I won't provide any discount if otherwise. So 0 otherwise. These are the things that we have to perform in the function called calculate discount. Now, here the first line of code will be the if loop. So we are trying to see if the revenue is 5,000, 10,000, in between, etc. So the first loop will be if revenue is greater than equal to 10,000. Then what will be the discount rate? Discount rate will be equal to 10%. What is 10%? It's 0.10. Now we'll do a else if condition. So we have else if revenue is greater than equal to 5,000. Discount rate will be equal to 0.05. And lastly, we have else. What else in else? Else it is 0, right? What should be the discount rate? Discount rate should be 0. And then we have return We don't want the discount rate to be returned, so we need return revenue into the discount rate since we need a value. Okay, now this is a module that we can reuse. Now we don't know what the revenue which we have given, so let's just run this code. So there is an indentation error. Let's pull this back, and return is outside the function, so let's just fix that with space and run it. So as you can see, there are no errors, but this is a function for adding different revenue and getting the output. Now, how do you get this output? How do you test this output? Again, take a cell and then type in sample revenue. Now, let the revenue be 12,000. And let's say discount. We need discount, right? Discount is equal to call the function. Now, what is the function name we have here? Calculate discount. This is the function name. And we have to pass in the value. So what is the value here? It's the sample revenue. You can directly pass the value, but if you want it to be organized, you can assign it revenue. And at last, we are printing it. So we have print revenue, and we are getting the return value from the sample revenue. And with that, let's add the discount. So here, let's see. First of all, I've given sample revenue as 12,000, and I'm then giving discount is equal to calling the function which calculates the discount here. And we have a sample revenue which is passed. So this 12,000 will be passed here. And then we have print revenue. So it should print revenue is equal to 12,000. The discount is 10% of 12,000. So let's just run this. And here you can see revenue is 12,000. The discount is 10% of 12,000, which is 1,200. Again, if you want a different value, you just need to change this value or call the function whenever necessary without even changing the function here. So this is the most important part of Python, to use the functions, to call the functions, because a hell lot of code will be saved, a hell lot of coding time will be saved, etc. Now let's see the difference between traditional looping and how you can loop it better. So let's say this has tips for Pythonic. So I'll show you two different versions of looping, so you will understand how previously looping would have happened and how now the looping is happening for better references. So firstly, let's say revenue is equal to 4,000, 6,000 and 12,000. Now if I want to calculate the discount loop, just first initiate discount loop, which is equal to an empty array, and then start with for r in revenue, let's say discounts is equal to calculate discount. Let this be in a box, in a loop. Now we need discount for r in revenue, and close the bracket, and then discount. Cut this part. I'll start from for r revenue. So after that, we have discount loop dot append calculate discount of r, close the brackets, and then we have discount loop. This should be out of the for loop, so just bring it out. So this is a normal loop calculating the discount. Now the same thing I'll code using Pythonic. How do you do that? First, let's say discount is equal to, let's say calculate discount, again with r, for r in revenue, and close the braces and just discount. Now both the things perform the same function or functionality. The only difference is list comparison let you build a new list in one readable line instead of multiple lines with append. So here you can code efficiently with less number of lines. Now let's move on to the next concept, which is enumerate, which we have already discussed. But here we'll do enumerate for reporting. Okay, this is not a text one, so let's just get a text one. Control C. Let's just delete this. So we need enumerate for reporting. Now how do you report with enumerate for the previous problem? First, start with a for loop for I, comma r. Here I'm using two of the variables in enumerate. What are you supposed to do it? Revenue. Now check if the revenue is there. So you can see revenue is there, but have I executed this line? No. Both the results are also same. The discount is 0, 300, 1200. I forgot to show you this, people. Both the looping will give you the same result, but considering the amount of lines of coding and also the clarity, I feel Pythonic is much better. For initial way, you can start practicing like that, then you will get used to Pythonic coding. Coming back for enumerate for reporting, revenue, the first loop is done. I need to print. Now there is another function called f here, which leaves a line f customer I plus 1 and close the braces, and revenue is equal to, what is the revenue here, r and comma discount, which is equal to discount in I. And let's close the braces and just run it. There's obviously a syntax error. I have not initialized this, and run it. So we do not want this. So let's just get rid of this and run it. And recognize skin again here. Just delete this part and play. So here, as I told you before, every customer is named here. Every revenue is named here. Every discount is named here. This happens when you use enumerate. It will pick the exact customer, revenue, and the discount part. So here we have customer 1, revenue so much, and discount is 0 because it is less than 5,000. Second customer is 6,000, it's between 5 to 10k, which gives you a discount of 5% of the amount, which is 300. Again, while considering customer 3, revenue is 1,200 and discount will be 1,200. So these are the important things about enumerate that you can use and have a specific value out of the list. Now let's move on to the next chapter, which is NumPy. Now if you ask me why we have to use NumPy in array, NumPy is stored in contiguous memory, enabling fast C-level operation compared to Python lists. So it is better than Python lists. Second reason is support element-wise operations without looping, which is vectorization for most. And then we have arithmetic and math functions included in NumPy. So let's just see a quick tiny example of NumPy. The first thing is to import NumPy. So the standard format is import NumPy as NP. So if you can run it, it is having no errors. Now let's just see how to initialize daily revenue in thousands, okay? So the first code will be here, revenue is equal to np.3, and we have braces so that the array is initialized properly. We have 10, 12, 9, give random numbers for practice, 11, 13, and 8. So this is a 1D array in NumPy. So let's just say this is np and run it. So this is done. Let's perform a basic operation here with the number. The first one will be revenue with GST. Now we all know that GST is calculated. Let's just calculate the revenue with the GST part. What should be the revenue GST part? It should be revenue to ever the percentage of GST is going. Now right now it is 1.18. So this adds up 18% tax. Now how this adds up? So as you can see, I've multiplied it 1.18. Now if you want to decrease it or you want to deduct it by some percentage, which is 10%, you can give 0.90. So 1 is a whole number. If you want to increase or add the tax, it is increased 1.18. Or if you want to decrease, it is decreased 0.90. I hope it is clear. And then let's give a discount price now. So discounted revenue is equal to, let's say, revenue into, I'm giving 10%, so it should be 0.9. So this applies 10% discount. And next, let's say sum in built in. So we have total week revenue, which is equal to, it's just revenue dot sum. What is this? This is sums is built-in function. So this will be sum and built-in function. This is a normal NumPy basics. Some of the key points to notice is there is no loop in revenue, which is 1.18 multiplies every element at once. That's called vectorization. So here, when you give array, every number will be multiplied 1.18 and then 0.9 and then included in the sum. This process, even without looping, is called vectorization. And functions like sum, mean, minimum, max are built into NumPy arrays and run very efficiently. If I have to do the same thing using loop without using NumPy, it will take me 3 loops to get the same. I hope this basics of NumPy is clear. Now let's move on to something called as indexing or slicing, and also we'll do some part of reshaping. The next concept is indexing, slicing, and reshape. Now indexing and slicing are same kind of thing where you're going to cut the array in whichever parts you want to. Suppose there is 10 arrays elements 0 to 9. You can cut it into 5 and 5, use the gaps. So we'll see an example for indexing. Firstly, let's initialize an array with the help of np. So let's say revenue is equal to np array, and again we are using the same thing, so we can just copy and paste it. So here, as you can observe, it is 7, so we can consider it as a week pattern. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, 7 days. So if I say revenue of 0, this is indexing. So this prints the first day, which is a 10. So indexing starts from 0, 1, 2, 3, 4, 5 and 6. So revenue of 0 will give you the information about the first day. Then if I say revenue of -1, now -1 seems a little bit hectic, but this will display the last day, which is 15 here. Now why we are using -1? We don't know the length of the, so if we know the length of the array, you can just length of the array -1, and you can also do revenue of 6. It'll give you the same value, but if you don't know the length of the value, you can use -1. And next, if you want between one integer to another, so for that we have a format. So I want to print work days. So for work days, we are having revenue from which day to which day. So from 0 index to the 5th index is the work days. So it's that simple. You'll get the first 5 values, which is 0 to 5. And what about weekends? Weekends is equal to revenue. And what is it regarding? This will be between 5 and above. Now we don't need to specify the last since the entire array is checked. So 5 and above will be considered. So this is more than enough. Now what if I want alternative values? It's again very simple. So let's say every other day, which is equal to revenue. Now we'll consider an entire array. So let's just leave the starting and ending as it is, and the gap should be every second number. So it is 2. So this will give us the alternative. So let's just run this. There is no error. So in a gist, indexing starts at 0. Negative index counts from the end of the index. Slice index is start, stop, step. So the starting value, ending value, and also the step count. Stop is excluded. So let's just print all these things and see. So let's say I want to print work days and weekends. So let's just fix it. And I need these both values. So as you can see, we have Monday, Tuesday, Wednesday, Thursday, and Friday, which are the weekdays, the first one, and weekends are 8 and 15 revenue. Now let's also print every other day and paste it and run it again. So here you have every other day, which is 10, 9, 13, and 15. So you can check these results in the same coding page. Now this is all about 1D array. Now what about 2D arrays? So for 2D array, let's start giving an array of 2D. Now how do you initiate 2D array? Let's say 2 weeks of data, which is equal to np dot array curly braces box. So here the first value should be, as usual, 10, 12, 9, 11, 13, 8, and 15. You can use any kind of sampling data as you want to. So for the second array, for the second day or second week, I will be using different numbers. Let's say 9, 11, 10, 12, 14, 9, and 16. So this is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And in week 2, again, we are back to 9, 11, which is Monday, Tuesday. So we are having 2 weeks of data here. So this is how you initialize 2D arrays. Now moving, we'll look into indexing part of a 2D array. So let's just run this. So here, let me just add a comma and run it again, and it should be fine. Now, how do you do indexing of a 2D array? So let's say we want week 2, only the week 2's data. So here we have revenue, call the 2W, and it should be 1, comma, index and leaf. This will print the entire second week. Now, since week 2 is done, this is the second block. So how revenue week 2 is what? The second part, and then until the end. Next we have, if you want to print Monday values, we have mon values, which is equal to revenue 2W. Let's say we don't want any indexing, we want from both arrays, from week 1 and week 2. So there is no starting or ending of this. So comma and then 0, the first index of the second part. So this will give Monday's value. So I hope this is clear. So let's just print week 2 and mon values and just see if there is any errors or will we get the output. So here you can see the second part, the second week is only displayed, and then we have both the Monday's value, which is from week 1 Monday and week 2 Monday. It is a little bit confusing at start, but once you start understanding how indexing works, it is pretty much easier to navigate via 1D or 2D array. Now indexing and slicing is done. Let's talk about reshaping. So reshaping is basically you have to convert 1D array into 2 to 3D array. So for that, let's initialize the first 1D array. Let's say the flat array, which is equal to flat is equal to np dot array curly braces, and then let's just say 1, 2, 3, 4, 5, 6, and let's just close the braces. This is a flat 1D array. Now, how do you convert this into 2 rows and 3 columns? So let's give matrix is equal to, the code for this is flat dot reshape to 2 rows and 3 columns. If you press enter, now we have converted the array into a 2D array. Now let's just print flat comma matrix. Let's see the difference. As you can see, flat is 1, 2, 3, 4, 5, 6. It's in one go, which is 1D array. Whereas the second matrix, you can see 2 rows and 3 columns, which is 1, 2, 3, 4, 5, 6. We have reshaped the entire array into the number of columns or rows that we are wanted. Now, how do you get back the original array shape? So for that, there's a simple code. Let's say back to flat. So here we have matrix dot reshape and given the amount of rows. So it's very simple for reshaping back again. So we will do reshape -1. This reverses the process. So let's run the code and there is no error. Now reshape changes the view of some data without copying in many other cases. Let's say -1 lets NumPy auto calculate the remaining dimension. The second thing is tied to analytics, which is reshaping is useful when you get the data as long as vector but needed it to be grouped by weeks, months, or even features. So let's move on to the next basic math and stats function, which is very much needed in data analytics. Now, what are the basic functions, which is average, sum? Now, what are the basic average function? For first, initially we use minimum, maximum, standard deviation, sum, etc. So let's see how you can code with that. So for that, let's again initialize the same array. So let's just copy and paste the same thing. You can try it with different values also. And then we have for mean value, it's revenue dot mean. That's all. You're done. You can calculate the mean. Mean is nothing but average. Now next one is median. Now here's a catch for median. Median is always recognized as function of the NumPy. So let's say np dot median and pass the revenue. So this is how you can calculate the median. Next we have minimum value. So rest all is normal functions itself. So let's give revenue dot min. Then we have revenue dot max, which is the maximum value out of the entire thing. And next we have revenue std, which is a standard deviation. And next we have usual one, revenue dot sum. So let's just execute this and see what are the results. So as we know, we have printed only the integer types. So let's just print all the values. So just adding the print statement. Since we are not returning any values, just calculating, I need the print values. So let's just give the print values. So now let's execute and get the answers for it. Here you go. We have the mean value of the entire array, median of the array, minimum value is 8, maximum is 15, and then we have standard deviation, which is 2.2, and also the sum of the entire array is 78. Now there is also function style for everything. Suppose we have calculated mean very rarely, commonly. So if you want the NumPy to get involved, it will be np dot mean and pass the revenue. This applies to everything here, even some standard deviation, maximum, minimum. Only median was I've given as np dot because it's a function of NumPy exclusively. Now these were the same basic statistics analysis compute in Excel, but now run instantly on large arrays. Many functions accept an axis argument for 2D arrays. So what is this axis? Let's figure out. So the next topic here will be axis. Now as of the axis, we have already seen a 2D array, which is week 1, week 2. So here the axis is equal to 0 for week 1 and for week 2 it is 1. This is the entire concept. So let's see a little bit of coding regarding that so you will have a clear picture. So firstly we have revenue, which is 2 weeks dot mean value and axis 0. This will calculate the mean of the first column. So this will be average across 2 days, 2 weeks. Suppose this will be an average for Monday of first week and Monday of second week. Now if the same thing I do it for axis 1, so this will be average across each week. So 0 is week and for each week it is 1. So if you run it, now if you look at this, the array will be 11.1428 and also 11.57. So this is across 2 days per entire 2 days, like Monday and Monday of first week and second week, and this will be the entire array of the column. Now let's move on to data frames and series. Let's say data frames and series. Now what are data frames? Data frames are collection of data. Now whatever we have done in 1D, 2D, there are millions probably of sets dealing with. The entire data frame will be denoted as df throughout the entire program. Now if I want to create a data frame, we can just say data is equal to, let's say, first day. This is the first column, which will have how many days? Monday, Tuesday, Thursday, Friday, etc. So let's just keep it with that. And next we have the sales value in column 2. So let's say sales is 120, 135, 150 and 90. Let's add one more column which says units, which will be 10, 12, 15 and 8. Here we have created a data frame. Now how do you initialize that? df is equal to pandas pd dot data frame, and we're passing the data in it. Now before that we have to initialize the pandas. So for pandas it is import pandas as pd. Let's just run this code. There's an error, so let's just figure it out. There is no comma, so let's just fix that and run the code. As you can see, it is converted the data frame. Now if I print df, it should be in a proper data frame format. So as you can see, we have day, Monday, Tuesday, Thursday, and Friday, and then we have sales as so and units as. This is properly converted into a data set. Now this is helpful when you have files that have data but is not in row format. You can just pass that via a data frame function from Pandas. Now here are some points that you should remember. First of all, series has index plus values. Data frame has rows. Rows is nothing but index, and columns, which is the names or the values. Next we have preview, Next we have preview with df.head, df.shape, df.info, df.describe. Now df.head will print the first initial 5 values, and then df.shape will give you how many vectors are there. Suppose rows into columns, what is the shape of the table. And next we have df.info. This gives the integer types of each column or row, whichever you want, you can calculate. And then we have df.describe, which gives an overall view of the table. Now importing datasets. So obviously we cannot form the entire datasets using manual typing. We'll have it in a CSV format, Excel format, etc. How do you load those datasets into a Colab or even Jupyter notebook? Both are very similar ways. Let me just open a new notebook so that it's clear. So even in the Jupyter, it's the same format. So here you can see a document folder. So you can just click on it, and here you can see an option called upload file. So you can just click on it and it will show you all the documents in your desktop. Any CSV file, you can just download it. There are 3 major documents that usually data is given. One is the CSV file, one is the Excel file, and one is the JSON format. How do you load the data set into a particular data? So here we have df CSV. This is for initialization. So this is any name. So I can give df.data is equal to pd read CSV, and then we have the name of the folder, which is, let's say, sales data CSV. So this is the format for CSV folder. Now what about Excel? For Excel, it is df Excel is equal to pd dot read. Again we have Excel, and again the name of the file, which is, I'll show you how to get the name of the file. For now, let's just consider this as sales data. Again, make sure it is in the inverters. And then here, if you want to mention any particular sheet name, so there will be several sheets. Now you want to consider only one sheet, so you can give sheet name is equal to sheet 1. You can rename the sheet and change the sheet name here also. Now coming to file, how do you get a JSON file format? So here it will be pd read, again the name of the JSON file. So let's say sales data dot. Now here this won't work because this is this format. So let's just change into Excel sheet. For Excel, this will be XLSX. Now here mostly I'll be using Excel file, but also works. You can use with Excel data as well, not an issue. Let's code. First, to show you how this works, I'll just upload sales data. So ensure that your files are saved elsewhere. Runtime files will be deleted after the runtime terminator. So this is a disadvantage of using Colab. So you will just have to reload the entire data, etc. So here you can see there is sample data which is there, and here we have sales.csv. Now it is a .csv folder. I'm starting with importing Pandas since BD is, and then let's load the data. Now how do you load? It's the first format, which is df.csv is equal to pd read CSV, and then we have, what is this name of the file here? It is inside .csv, and you can just run the code. Let's just say df. Let's the data frame just be named as df. So here we have the data loaded. How do you know the data is loaded? So you can say df.head and the initial values of the data set will be printed. So you can see days 1, 2 and revenue, these are the things. Now is df.shape. Now this will give the shape of the thing, which is nothing but rows and columns. We have 7 rows and 2 columns. Now if we say df describe, here it will give you the count 7, 7. So here you can see if I count the entire days, it is 7, revenue it is 7, the mean of the entire days is 4, etc. All the things which is minimum, mean, standard, deviation, 25% of the set, 50% of the set, 75%, and max is also printed just by one code, which is describe. Let's move on to the most important part of data analytics, which is data cleaning. Most of the time is gone in data cleaning since the data that we receive is not clean enough. It might be from a random Excel file, a random YouTube comment, etc. So we don't know actually what are the values in that, and since it's lacks of data in one sheet, we have to clean the data. Now it's not easy if you go by it one by one. So we'll figure out a way to do it in a much easier way. So for that, I will first upload a data set. First, we'll see a very small data set and then we'll move on to a real-time data set and how to clean them. So firstly, let's upload. So as usual, we'll just upload the file. It is getting uploaded. And what is the first thing that you're going to do? We're going to read the file. So we have df is equal to pd.read. What kind of file is that? CSV file. And then we have the name of that will be sales6.csv. It's not uploaded, so let's upload it again. Okay, now it is uploaded and let's read this file. So pandas is, since I have not executed pandas, let me just execute pandas and then run the program. Yeah, so it is loaded. So next you can describe, you can do head, you will know what are the things that there are in the data set. So we have df.head. Let's see what is the data set, what are the initial values of the data set. So we can see we have days, sales, unit and region. Okay. So the next concern will be if there are any missing values. Since we get data which is not really appropriate to feed the system because it has a lot of gaps in the value, to calculate that we have a simple code. So we have isna is basically is null values dot sum. This will calculate the amount of null values present in the entire data sheet. So attribute data from sum. Okay, we have not also imported another function. Let me just import NumPy and then go back here and run it. It's not there. So which is the other one missing? So if I run that statement, which is df.isNull.sum, it'll give every column and the amount of null values it is having. So for the day column, we have 0 null values. For the sales, we have 1 null value. That means we have 1 empty value. For units, there is none. And for region, there is none. So this is how you identify how many null values are there. And with repeat. And how do you deal with those null values is up to you. You can either replace the entire null values wherever it is by mean, medium, mode. You can either drop the entire column if it's not mattering that much. So we'll see how to do that also. So before that, let me get the information of the data frame. So here we have 9 non-null objects. And once for 8 sales, we have 8 non-null. That means 1 is missing, and we have, so the entire data set is about 9 values. Okay. So since the value that is missing is sales, we can replace it by the average amount of sales in every day instead of dropping the entire column. You can do it by most repeated, which is the mode, where you can do it by either the average of it or mode or medium left to you. So how do you? So if you want to drop the entire column or a row, this is the code that you will be using, which is df dot is equal to df dot drop and then curly braces. Here we have and the column name, whatever column name you're going to drop, that one. Suppose I say column 1, and you have to mention the axis also. So axis is usually 1, but if you want to drop the horizontal one, you can change it to 0. This is for dropping the column or the row, and you can change the axis as per desired. Now, instead of this, if you want to fill the null columns in the desired number, you can just do df dot fill null values and give the value. So usually they give 0 so that it's 0, and you can calculate the rest of the data set like that. If you want to give any specific number, you can go ahead and give the number. So I'll add this to the X, so you'll have a abbreviation of this, and this will be dealing with missing values. I'm not going to do any of this because it is sales value. Now what is the another way that you're going to deal, which is the mean value. So for mean value, we have to calculate the mean of each individual column and fill those column null values. So here I'll be pointing out to the sales column because that's the column where the null values are. So df.sales, let me just check if sales S is capital, and it is capital. And here it is, individual ones. Sales column is equal to df, and the sales, what is the next? Dot. You have to fill the column here. Fill NA, df. The columns, if it is mode, you have to give dot mode. If it is median, dot median, etc. So here I'm going to give a mean value, since that will be the closest sales value if they have skipped in the dataset. So let's just run this and see if the sales value gets filled. Now let's cross check with the sum of the null value. So since I've replaced the null value with the mean value, here it shouldn't show me any other null values, especially in sales. So let's just cross check, and here you can see it has changed back to 0 since we have filled it with mean. Now for mode, just replace the mean by mode. If you want it to fill by median, just replace it with median, and the entire column will be filled. Now make sure use your intelligence to see which category should be replaced by mean value or most repetitive value, which is the mode value. Now after filling the null values, the next concern will be duplicates. What if there are duplicated values? So how are you going to detect the duplicate values? It's very simple. We have df.duplicate and sum. So if you run this, there is no duplicated values in the above, or else it will give you a number. But you can again deal with the duplicated is similar to dealing with null values. Either you can drop them. Usually people drop them since already a copy of them exists in the dataset. Now after identifying the duplicated values, our next concern, which is a major concern, will be outliers. As we all know, outliers are extraordinary range of numbers. So suppose the sales value is between 1 to 100, there will be one value which is in thousands, which is an outlier. So we have to detect that and resolve that, either delete it, replace it, etc. Same as you did for your null values. So firstly, we have to identify the outlier. Here I'll be using IQR method. That means I'm going to divide the entire data set into 4 parts: quartile, first quartile, second quartile, and third quartile, and then we'll figure out how we are identifying the outliers. So first we have to import Pandas and NumPy. That's a usual. Then let's assume df from. Now I will consider another data set, and let me just say df is equal to df dot read CSV, and what is the name of the folder? It is sales 5, and just run it. I'm taking this because there is a little bit of outliers over there, so I can identify. So let me just correct that to PD. So here it's sales.5.csv, and let's put this in double quotes. Okay, here the S was capital. Let me just change that to, and run it. So we have loaded the document. How do you find the outlier now? That's the major question. Firstly, I'll be assigning Q1, Q3. Now what is Q1? So the formula is df, whichever column you want to find the outlier in, quantile, which is 0.25%, which is 25% of the entire data set. And similarly, what will be Q3? It will be 75% of the data set. So let me just copy and paste this and change to 75%. Now we got the values 25% of what data set and 75% of the data set. Now, what is the value of IQR? This will be the difference between Q3 and Q. After calculating the IQR, we have lower. I'm just initializing lower, which is equal to Q1 minus 1.5 into IQR. This is standard kind of formula. Then we have upper, which is equal to Q3 plus 1.5 into IQR. Since we have lower and upper also calculated, let's move on. How do you get the outliers? So here outliers will be the data set, which is the column that we have considered. It is sales, which should be lower than lower. So which is lesser than the lower target margin that we have set. And also I'm adding an OR function. DF of sale should be greater than upper. Then let's just print the outliers. So let's just execute this. There are errors. Let's just identify those. So here make sure to leave a space and run. So we have empty data frame and calls as day, sales, unit, region, and index is 0. So according to here, we don't have any outliers. So I'll just show you why we don't have outliers. So let me just print df.head. When I will be executing in other data sets from an online data source, which I'll be explaining later, you will definitely have an outlier. So here in the sales, we have regions from 90 to 120, 135, 150, which is fine. If there was something like 1000, 2000, it would have identified with the column name and with the matrix name. So after identifying, again, you can specify the outlier, replace it with any kind of number you want, whether it's mean, medium, mode, or even give your number as per your calculation, whichever suits the best in your data set. Now, how do you visualize this one? So for that, we just need to plot. So let me just consider this df.boxplot. This is a usual way of plotting the outliers. Let's say column. What is the column name? It is sales. So here, as you can see, there is a box plot. So if there is any outlier, there used to be marks here, or if it is lower than 90, it used to be here. I'll show you one example with outliers. So you'll be able to identify with outliers how it is and without outliers how is it. Now the next important topic would be normalization, which is standardization and normalization. So what is standardization and normalization? In simple words, I'll explain you. If I have a data set of 10, 20, 30, 40 and 50, this data set, and I have one more data set which is 1, 2, 3, 4 and 5. So in these two data sets, which one is easier for the system to process? In the fact, when you look at 10, 20, 30, 40, 50, you will find that it is large scale of numbers. Even if it is 100, 200, 300, 400, 500, it's a little bit complicated to work with numbers. Whereas if you go with 1, 2, 3, 4, it's much easier. Now, why do we perform standardization and normalization? Is that because when you give simple numbers, this is the same numbers. If you put it in the data set, we have the same mean, same mode, and it won't affect that much of a correlation of the data set. It will be easier for the system to process the information also. So for that, how do you perform standardization and normalization? Firstly, by using Z-score. So first method is by using Z-score. For that, we need to import scikit-learn dot pre-processing import standard scalar, which is used for normalization. So when you run this, it is successfully run. And then next, if you go, we have already seen the sales value here. I'll show you. This are the sales value. So we are normalizing these values. So how? By passing through the standard scalar method. Now, what is the formula or code for that? We have df. Before that, let's install scalar, which is equal to standard scalar. It's a function which is having inbuilt function. So let's not have a gap and just run it and it's done. Next, here we have to normalize or standardize the column of sales. So we have df.sales is equal to scalar.fit. We're fitting the module fit transform, and then we have df sales. So here the fit transform method that we have initialized here, we are fitting the module here in the same column and then running it, it's run. Now what do you think the sales value will look like? Definitely the values would have changed and reduced in size for the computers. So here you can see we have values of 0 0.06, 0 0.71, 1.36, minus 1.23, etc. So it is reduced. Now how it is reduced? It is either divided by the same number, or let's say it has standardized valuation factors that it can scale down the numbers. So either it will be dividing the number with the repeated ones. So here either it will be divided by 110 or so. So these values, which is huge number of values from 150, it is changed to 1.36, which is the highest. Here it is easier to take a look at the sales. Here it is 0 0.06. Okay, the sales, and which is the highest. Here it is 1.36, and a little bit less we are having on Thursday and Friday in the sales data. So it's easier for us to also read the data and also for the system to absorb the things. Next, let's talk about normalization. For that, we need min-max scalar. So it's also another function of the scikit-learn. So we have min, import min, max scalar, and then function. Now function is not required here. Just run it, and in the next function, let's install that in. So let's say scalar is equal to min, max, scalar function, and let's normalize the sales itself. So here just copy and paste and change the scalar here. Okay, now let's just run it, and it's run, and let's see the output. Now what should be the values of the sales? So here, as you can see, there is no minus value, but it will range from 0 to 1. So normalization is basically any tons of data in lakhs amount of data, it will be converted into values between 0 to 1 in point wise. Usually data analysts prefer normalization since there is no negative values and it's easy to work with the data in that way. So here, how do you normalize the values? So the highest value, which was 150, is divided in the sales value. So the first value will be 120 divided by 150, 135 divided by 150, 150 divided by 150, which is a maximum value, which is on Wednesday. And then we have Thursday 90 divided by 150. And on Friday, we have 110 divided by 150. And that's how you receive these values. Now this makes more amount of data in lakhs or crores rupees come down to 0 to 1. So it's easier for us to model the entire data set. Now, another way of making the data set easy for the system to process is encoding. That is, if there is any categorical value, which is, as you can see here, we have region as north and south. So for the system to take in the string, it's difficult. So what do? We encode it if it has 2 or 3 values max. So if we have north and south only, we can encode it with 0 and 1. So the system actually understands the region. So as we all know, the system only understands numbers. So we have to convert any kind of string integers or any kind of things that you want to process the information in to encode it. Now we have many kind of encoders, including one-hot encoder, etc. So here, since there is only 2 categorical values, we will be using label encoder, and also I'll give you an example of how we can use one-hot encoder. So basically this part, which is the string part, should be changed to zeros and ones. So for that, what is the code? Firstly, we have to import both the type of encoders. Now again, for label encoder, it's pretty much simple. We have from scikit-learn.preprocessing import label encoder, and we have label is equal to label encoder. Now we have to pass this, fit this to the entire module. So we have df, what is the column that we are targeting here? What is the column? column name is region. So give region, which is equal to df region map. Now here dot label, since we have to fit the label, and then what are the values that you want to replace, you have to mention here. So for that we have, what are the values here? North and south. So just open a curly braces and say north, replace north with 0. And is there any other value? Obviously it is south. So we have south to 1 and close the bracket. Now let's see how this works. That is an error, so hash label. So I have just did a small change in the code. Since it's a label encoder, the first value will be considered as 0 and the second value would be considered as 1, and these are the only two possible values. So I don't need to physically type in the values. So I've just given df region is equal to label dot fit transform, and I'm fitting the entire column in. So if I run that, as you can see, region here, the north ones have changed to 0 and the south ones have changed to 1. So it's numerical value so that you can fit the same data into the other modeling. Similarly is one hot encoder, but the difference is one hot encoder uses dummy value. Now here are some things that you should keep in mind. The first thing is document changes, that is notebook comments plus version data. So you have to keep in mind which version is actually being run in this same system. I would suggest you to go with any cloud-based profile so you don't have any issue with the versions. Then we have to validate, recheck the df.describe once you get the notebook. Then about pipelining it, change the step. For example, we have df.pipe clean outliers.pipe scale features. So you can use this instead of all these things. Then we have business context. Outliers must be VIP sales. So flag don't auto drop. So if there is any big amount that is purchased, so here the sales value were maximum 150, but if there is 1,000, do not drop the column, just flag it as a VIP sales so you don't lose the data. And also about the so also you can use seeds for random ops save preprocessor, which is at pickle.dumpscalar, and then you can run it in your command prompt as well. Next, I'll show you how to use real world data which you can extract from Kaggle and how to start cleaning, visualizing, analyzing, etc. So for the data, the first step is to open Kaggle or any other platform that you will want to get the data set from. So this is Kaggle. Here tons of data are given on each domain, let it be house price prediction or any other kind of data that you want to work with will be here. So search for the data and start learning. So we'll just sign in. So as you can see, we have competitions here, the data set, different kinds of data sets, the models, benchmark. There is a game. It's a fun game way that you can play and learn coding as well. We have discussions, code, learn, and more. So if you come to data sets here, we have some trending data sets. So we have synthetic healthcare patient journey data set, global earthquake, India's top 100 universities datasets, custom shopping behavior analysis. So if you click on whatever dataset you need, you'll have data card which has a description of the data. So you'll have an idea of what the datas are like. A df.describe function that has run. So total rows is 3,900, columns we have 16 columns, and here are some of the columns here. What are the categories, etc. So we have 16 columns, etc. You can just clean this data, try to find out some insights. So when you come to code, there are multiple people with the answers for this code of cleaning the data. So they have posted their notebooks. You can just go through this, go through how they have approached the data. We have the input data as well. So here input, what will be the output, etc. Even you can also start creating a profile, start creating your notebook based on each data set. There are competitions that are raised, so they'll post a data set and ask insights about those. There are competitions over here also. You can happily mention in your resume that you have worked and you have achieved something in Kaggle profile. You can add the Kaggle link to your resume as well, which is a plus when you're giving for interview for a data analyst positions. So when you join a company, your data will come from the company's dataset, not with Kaggle or any other one. Maybe they are sharing the datasets with you, or you have to pull it from a cloud. Now for my next segment, I want to use a retail dataset. So let's search. So I need datasets. There are about 4,900. So let's see. I think this is fine. Retail sales datasets. Let's just see the data card actually. So as you can see, we have the columns of transaction ID, date, customer ID, gender, age, product category, etc. And what is the amount of the columns? Is it present? It is having 9 columns, and I'm not sure about the number of rows. So we can just download this and it will be there in your system. And let's create a new notebook, name of retail, since it's a retail data set, and upload it as usual that I showed you. Upload the file. It'll take some time to connect to the online, and you can just upload. So here my data set, and here. Now let's just import Pandas and NumPy. This is the first thing, and then import NumPy as NP. I'll also be importing Scikit-learn because that is also very important part. And for visualization, I'm importing Matplotlib py plot as plt. Plt. And I'll also be importing Seaborn. And for modeling, we'll figure out the modeling part. So as of now, these are the important libraries that I have. So first thing, df is equal to pd.read file csv. And what is the file name here? We have retail dataset.csv. Now this loads the data to a df, which is a data frame. You can name the data frame as your wish. df is a data frame that we had installing. And next, the first step is to df.head and run it. So as you can see, we have transaction ID, date, customer ID, gender, age, product category, quality, price, unit, total amount, etc. These are the columns. And let's just check on the data, the analytical part. So here we have count, mean, minimum, repeat, count, mean, standard deviation, minimum 25%, etc. So count is 1,000, etc. So you can just go through this, and as usual, the first part will be calculating the. Now let's see the number of rows also. So here we have 1,000 values, which is 1,000 rows and 9 columns. Okay, that's not a bad value. And then just move on to the next one. Let's calculate if there are any null values. So what is the formula for that? Dot sum. And is there any null values? Absolutely no null values are here, and the types is integer. Just let's take a look at what needs to be done here. So we have gender, male and female, age, so product category, we have beauty, clothing, electronics, and I think clothing, beauty, etc. And quality also, we have price, unit, and total amount. Now, once the data is clean, the next is to visualize the data and have a little output from the visualization of the data. That is to drive in inputs. Suppose if you want to know what are the top selling products, you can get the information via visualization. And if those are helpful, we can produce more number of amount of that product to increase the sales. So this is how a business simple problem leads. So as we all know that we have already cleaned the data, not much was there to clean, but you can just let me know if you are finding difficulty in finding this data sets in the comment section. I'll be happy to share you the link. But I've taken the data from Kaggle, and I've also shown you which data set I've taken, so you should be able to pick that data set as well. So here, coming to visualization part, which is mostly mapping, creating bar charts, n number of charts, and seeing what is useful and why it is going like that, we have to implement the ideas. The first thing important is obviously Matplotlib and Seaborn. So here we can see sns.set theme. So we are setting the theme, which is white grid. So whatever output we are getting from this plot will be white grid We have multiple themes. You can just Google it and apply it here. And we have df is equal to pd dot read cs. Again, I'm just reading the same data set. And df date pdf date time. So we are considering the date. We are plotting one side is the date and the second side is revenue, which is quality into the price unit. The entire revenue will be the quantity into price per unit. That is that we are plotting. And then we just need to plot these. And if I execute this, so here I have a added column in white and black, correct? Which has calculated revenue, which was not there before. So revenue was not here before. So we added a revenue column since it's important to know which product is earning how much money in total, not in terms of per unit. So here revenue was per price unit into the total amount. Next, let us discuss some Matplotlib basics, which is line, bar, and histogram. For line graph, first thing you have to figure out the size of the plot that you want. So first we have plot dot figure. Fig size is 10,5. You can increase and decrease as per your requirements. Then we have monthly revenue is equal to df dot set index. So setting as date. And then we have resample m and revenue dot sum. So we are resampling the revenue because we don't know if we work with the original data, we might lose the original data. So we are resampling the data and using it to plot. And then we have to plot these two. Plot, which is monthly revenue index in the index part. And then we have monthly revenue values as a chart. And the label is total revenue. So the entire plot will be given a label of total revenue. Now what will be the title? We have given title as monthly revenue trend, which is retail data set, and the X label. In X axis it will be month and in the Y axis it will be revenue. And we have X ticks rotation is 45, legend, and we have also grid as 0.3, and we have PLT tight layout. And then for reviewing that, for us to show, we have PLT.show. So if you run this, you'll have a map that is figured out here. So here this is the total number of revenue and which date. So it's easier to look at this and say which is the highest selling date. It's between 2023 to 2027, which is probably the 6th month is the highest selling landmark, which is around 40 to 50,000. It is 50,000 and above. This is the 6th month of 2023. And if you go here, the lowest is as of now this point marked, which is 2024, the first month of January, we have dip. So you have seen here the x-axis has month and in the y-axis it's revenue. And if you observe here, the title of the entire graph is monthly revenue trend, which we have given it here. It's very simple to plot graphs once you get the hang of it. Next, we'll see how to plot a bar graph. Firstly, we are having revenue, categorical revenue, which is DF group by product category. Now we are grouping by product category because bar charts requires a product category so that we can each product so much sales or so much revenue is generated. We are grouping them by product category and its revenue, and we are adding the sum. And here again it's the same format, fixed size, the chart, the title of the graph, X label, Y label, X trig rotation, grid, and title of the layout. This is important since when you see the data set here, we have beauty. We are calculating the revenue. So how will be the revenue of the beauty category calculated? So it will be 50 plus any other beauty category is there. That will be the total revenue. We'll see which category is giving us more revenue. That's the point of having a box plot. Usually it's calculated, one is categorical versus the other is the numerical, which is the revenue. So one side it will be categorical. Usually the X line plotted will be the categorical value and Y will be the numeric value. So let's just plot this. So as you can see, we have three categories. We have electronics, we have clothing and beauty. I think the highest would be electronics, which is around close to 16,000. And beauty is also across 1,40,000 revenue. So here it is easy to just look at this graph and say we have to concentrate on electronics and clothing more than beauty since they are giving more revenue for us. Now moving on to histogram. Now, histogram is a graph that is plotted both by revenue and other also is numerical value. So again, first, figure size, and then we have plot histogram of revenue. We are having bins, edge color black, alpha 0.7. So here, whatever things that you can see can be changed by adding values here, or if I consider here, you can add it over here, or you just need to explore what are the values. You can change the alpha value, you can change the color. Since this is blue, you can change it to black value. You don't want this grid, you can change that too. You just need to figure out how. So you can use OpenAI tools or even Gemini to figure those things out. And then here, coming back, we have given the title of distribution of order revenue, revenue per order, frequency, etc. So let's just run this, and you should see a histogram here and the frequency. So people who are ordering less than 250 rupees is more compared to people who are ordering 1750 plus. There are some people who are ordering around 2000 per order. So we can concentrate more on the less revenue products. So that is selling more for us. The frequency is more, people are buying them more. So it is crazy that with a graph, the entire data set, if we would have checked that, we would have not got these insights. But once we plot these graphs, we are getting an idea of which is the highest selling product or which is the top category value, which is giving us the revenue as good amount of revenue. What are the things that we should concentrate on? What are things that we can develop in future to make the sales or revenue go up, etc. can be shown here. Coming on next, we have bar plot. So this is usually any kind of graphs either tells us a story, a feedback, or any kind of thing that you can actually adapt it and change the revenue or the sales. So here for, again, I have fixed AX PLT subplot, and I have multiple number of bars and grid graphs here. So for here, I'll just run this and I'll show you. So you have seen, observe the same diagram above here, but it doesn't have the exact values here. So I've just added those values here. So it's 1,56,000, 1,55,000, and here I have bolded the letter. How? By changing a really small details, which is, as you can see here, we have barred get width divided by 2, height also we have defined, and we have X rotation 5, etc. So here you can see font size also we can change, and you can bold the numbers or even the heading, font size, and bold it. So you can play with different which kind of graph that you want, etc. That is done. So here product category is same, total revenue is same. The only things that I've changed is I've boldened the heading and the numbers here I've added. So for adding the value on the annotation, we have max value is equal to cat revenue.max. For bar in bars, height is equal to bar.get height. We are getting the height of the bar, and then we are adding ax.text. Now we are putting a text value which is bar.get x plus bar.get width divided by 2, and then we are adding the value here. This is a major part where we add the value, and how it is placed. It is placed in the center of the box, a little bit bottom side. And then we have font size 10. You can increase it 10, 15, 20. Then you can have font weight as bold. Now, if you don't want bold, you can just delete this and run it. It will be normal without no bold. So play with your graphs. Which kind of graph will be appealing for your stakeholders to make them understand more easily? You can plot any kind of graphs over there. Next, let's talk about Seaborn basics. So here, there is one more thing I would like to tell you is about the AIs that is arriving for coding. Even in VS Code, you have inbuilt Gemini so that you can use for coding. So any other AI that is coming, it can be Gemini, it can be ChatGPT, etc. So this collab has inbuilt Gemini. So it's showing me this is not the sentence, this is the correct sentence. So it might be some minor errors. So you can just fix it. So still it's running, but there is a major difference here. So you can just cross check it and identify the errors. So Seaborn basics, again, Seaborn is for a little bit more complicated data, I would say. Again, the figure size is there, and we have bar plot. The coding is much simpler in the Seaborn as compared to Matplotlib. So here in one line itself, you will have an entire graph which is plotted. So here we have x in the sense the horizontal, and then we have vertical y revenue, estimated sum, error bar, palette is where it is, and then we have, it's just this one sentence that is plotting this much. Now how do you add color, box plots, the titles, etc. is in the next step, which is the title is given total revenue by product category, which is Seaborn, and then we have X rotation 45, which is normal, and then we have Y label. Y label is total revenue in dollars, and then PLT dot title layout and PLT dot show. Now this palette is basically giving different colors to the different bar, so that's how we get different colors here. You can also remove this lines over here as you wish. Just experiment. When you're coding, you'll slowly understand what are the things that you can change, you should change, or how it is looking good, better, etc. Now coming here, why do I think Seaborn is better? Firstly, it auto sums. There is no need of creating another column for auto sum. And then we have color palettes. As I showed you, there are different colors. And then we have error bars, which is hides nothing. So in the Seaborn itself, let's plot another box plot for revenue by region. So which region is giving us more revenue? So for that, again, we have plot figure fixed size 9.5. SNS bar plot, we have X and Y category over here, which is product category and revenue. Estimator is equal to sum. So we are just adding, we are just giving this. So it sums up each category's regional revenue. And then again, the same palette I'm giving. And then the title, total revenue by product category, font size, font weight, etc. X label, Y label, X tricks, again rotation 45. And then we have PLT grid axis is equal to Y, alpha is equal to 0.3, etc. And then we have PLT dot title layout and PLT dot show. Now if I run this, you can see total revenue for beauty, it is so much, and electronics, it is so much. So for different categories, we have different revenue. And this is done by SNS. So if you compare both the code, I feel Seaborn is much easier to understand and code with. So go with SNS itself, which is the Seaborn. Next, regarding heat map. Okay. So heat map is usually plotted before visualization to see if there is any chances of dropping any columns. So heat map is basically correlation matrix. So I'll just get a heat map and I'll show you. So this is the heat map. This is the revenue. So revenue is 1, price per unit is 0.85, and quality is 0.37. So here you have to keep in mind that only the numerical values are plotted. We have not converted any categorical or string values into numerical values. So if you change that, we'll get all the numerical values also. So suppose if I have another column as number, person's name, that should not really affect my revenue here. We don't want anything to do with the people's name who have purchased. So here, if the correlation is plotted, if we convert the people's name into numerical and then plot correlation, this literally will give you a value of 0, since there is no correlation between that category and revenue. So if you look at this quantity and price per unit, this is showing 0.02. It has no relation. So if your end product is dependent on price per unit, which is not here. For us, it is revenue, and all other quality measures are applicable here. You can easily drop, if your concern is price per unit, you can drop the quantity column. That's not an issue. So seeing this correlation graph, you will know which column is more important, which column is less important, whether to keep that column or drop the entire column. You can just identify in just a look. Now let's see the code for plotting this. Firstly, we have to select the correct numerical columns. So we have quality, price, unit, revenue. You can select any numerical data. Keep in mind, it should be any numerical data. Now let me just add one more column. Let me add transaction ID. So let's just give transaction ID and run this. So here you can see transaction ID is negative for quality, and transaction ID and revenue is negative 0.08. Our concern is to how to increase this revenue. So Since the Y, that is the revenue, is most important, we can drop transaction ID here, this part, since it is negative 0.08, because obviously transaction ID is nothing related to the revenue part. And here if you come, the simple formula or the code is CORR is equal to DF numcalls dot COR. Then you can plot, you can figure the size out, the heat map, the anode, the whatever color you're choosing. There are different tones also in this correlation map. And here we have plot title, we have correlation between numeric features, font size, font weight, etc. And then layout and purity dot show. So correlation is not just a storytelling way, it's also a way that tells us that this column is not important for us to move it for any other further machine learning modules, etc. And coming to pair plots. So as I told you earlier, any kind of graphs that you're using to plot, it will tell you a story. And here we'll see pair plot. So first, I'll just execute and let you know how the pair plot actually is. So here you get all kinds of graphs possible from the table. Each quality, again, numerical quality will be paired up with another numerical quality and given us. So here you can see revenue and price per unit. And here you can see quality and price per unit, revenue and price per unit. So we don't need to individually plot any other graph. And you can see gender here is male and females. And revenue most is generated by males, revenue and revenue. So here you can see the females are at the top and the males are at the bottom, but revenue mostly is generated by male people. And I can see like more of the male people here rather than the female in the high category. And in the low category, if I go through, it's mostly females. So you don't need to plot any other individual things. Again, you can add or delete or add n number of columns that you want. Again, it should be a numerical value. And we have the kind, if you want box plot, you can go with box plot. If you want histogram, you can go with histogram, but make sure it is compatible. So histogram is for both numerical values, and other such as box plot is for one categorical value and one numerical value. So make sure those are compatible. And coming here, the next part is storytelling. Okay, so this is the final work of a data analyst, which is storytelling, which is the most important part while you're communicating. You clean the data, you visualize the data, but at the end, we need a story, we need inputs, we need what are the things that we have to change to increase the revenue, what are the things that are ranking, etc. So here I'm going to show you two ways. We are going to calculate top 5 products by revenue in this entire data set with one plot. And then the second is monthly revenue trend, which is the second one. So these are helpful when you're trying to have a meeting with your stakeholders. It is helpful when you tell the stakeholders that this is the story, this is why we are increasing the number of products, because this is selling more, etc. You can just prove it with numbers, with graphs. So firstly, for top 5 products by revenue, we have to group by category. As I told you earlier, it's product category revenue dot sum. Repeat. Sort values and ascending is equal to false and head of 5. Again, this is the plotting part. So you can just go through this, and we have value annotation as well for bar in bars, etc. So when I run this, I should get the answer to my top 5 products by revenue. So what are my top 5 products? Ranking top 1, top 2 and top 3. In which revenue? This will be beauty and this will be electronics. So this is the highest ranking one, and categorical rank is also there. It's given in the order wise, rank 1, 2 and 3. And there is a prompt which says which category dominates the revenue, cross sell or bundling opportunities. So you can add various questions also, but here if it is any other thing in rank 1, it would have showed rank 1, but since it is electronics, it is showing electronics. So we can easily identify this is electronics, this is beauty and this is the other one. And the next question, what was the next question here? It's monthly revenue trend. What is a trend that is going on monthly? So here let's go out again, similar kind of plotting. Monthly is equal to df.setIndex date. Firstly, we are setting the date since we have to calculate via monthly, and then sampling the revenue, plotting You can just pause the video and see the code and try it for yourself. I'll also let me know in the comment section if you want these notebooks added in the description box. And let's just run it. What is the monthly trend? As you can see, the highest revenue that we have gained is between 6th month of 2023. The lowest is 2024 Jan. So you can just see what is the peak season, what is the slow season, etc. So highest will be around June, so you can launch more products during June, give the consumers varieties, etc. So this is how you can answer various questions that can actually increase the revenue. Now that you have completed this course, here's how to turn these skills into a career. Step 1 is to practice with real datasets. Work with Kaggle and open datasets. Repeat the full flow, which is clean, analyze, visualize, and explain. Step 2 is to build a strong portfolio. Create 2 to 3 analytical projects such as sales performance analysis, customer behavior insights, business dashboards. Focus on insights, not just the code. And step 3 is add SQL to your skill set. SQL plus Python is most common requirement for data analyst roles. Step 4 is to master data storytelling. Explain charts in simple business language. Always link insights to decisions. And step 5 is to prepare for interviews. Be ready to explain your data cleaning logic, your EDA approach, and why you choose specific visualization, and also how you automated reports. By now, the full picture of data analytics should feel clearer. How raw data turns into insights and how Python fits into every step of this process. You have seen how analysts work with messy data, cleaning it, explore patterns, visualize results, and automate repetitive tasks. It's learning a way of thinking. The real progress from here comes from practice. Pick datasets that interest you, ask questions, try explaining what data is saying in simple terms. You don't need to know everything to move forward. What matters is staying curious and consistent. If you keep applying these skills to real problems, you won't just use Python for analytics, you'll begin to think like a data analyst, and that's what truly makes the difference. If you found this video helpful, do like, share, and subscribe to Simplilearn. And if you have any queries, do let us know in the comment section below, and our team of experts will get back to you as soon as possible. Until next time, keep learning with Simplilearn.